Welcome to the largest construction site in Europe today, the $7.5 billion megaproject, where humans are executing an audacious ambition to completely transform the infrastructure map of an entire continent. An 18-kilometer immersed tunnel connecting Denmark and Germany directly, assembled from massive concrete blocks weighing up to 73,000 tons each. This is not just a road. This is the greatest engineering feat of the 21st century, Fehmarn Belt fixed link. Take a look at the transportation map of Europe. You will see a massive economic highway called the Scandinavian Mediterranean Corridor, stretching 4,800 kilometers from the icy bays of Finland down to the Mediterranean. But there is a bottleneck choking this flow. That is the Fehmarn Belt Strait. For decades, millions of tons of goods and thousands of tourists every day have faced a paradoxical reality. To cross this 18-kilometer strait, you only have two choices. One is to wait patiently for 45 minutes on slow ferries. The other is to accept a 160-kilometer detour through the steep mountain roads to the west. The result? $80 billion. That is the price the European economy pays every year just for this delay. A figure large enough to build dozens of other megaprojects. So why wasn't a tunnel built earlier? The answer lies beneath the Baltic Sea. A geological trap of hard limestone mixed with soft clay makes conventional tunnel boring extremely risky. Lowering tunnel boring machines into these conditions would be little more than a gamble. Engineers needed a solution that broke away from traditional methods. Instead of drilling through the seabed, they chose something unprecedented, building the entire tunnel on land and then lowering it onto the ocean floor. That decision marked the start of a true engineering revolution. So how did the engineers achieve this? Let's step into the heart of the project right now. Don't forget to like and subscribe to support us. Let's get started. Unlike mountain tunnels or underground bored tunnels, the Fehmarn Belt project uses the immersed tunnel method. In simple terms, the tunnel is placed directly onto the seabed using prefabricated concrete sections. With an average depth of around 30 to 40 meters below sea level and a total length of 18 kilometers. Experts concluded that this method is safer, faster, and about 15% cheaper than boring a tunnel. One defining feature of the immersed tunnel method is the construction of a dedicated factory to manufacture the components. This allows work to be carefully controlled while reducing the impact of harsh environmental conditions offshore. It took 2 full years just to build this 500,000 square meter factory in Rugbyhavn, Denmark. It is one of the largest factories in Denmark and exists for a single purpose: producing concrete elements weighing tens of thousands of tons for the Fehmarn Belt fixed link. The factory covers an area equivalent to 200 football fields and is large enough to store 89 massive concrete elements, each 217 meters long and 40 meters wide. The scale is hard to grasp. If one of these elements were stood upright, it would resemble a skyscraper. Combined, all the elements would form a structure twice the height of Mount Everest. So how are these enormous structures actually made? Let's step inside the factory to see this one-of-a-kind process. The first stage is the production of reinforced steel cages, known as rebar cages. These provide the tensile and bending strength the concrete itself lacks. Steel bars are cut, bent, and assembled precisely according to design drawings, then tied together to form complete cages. Once finished, the rebar cages are lowered into enormous formwork systems that hold everything in the exact structural position. Concrete is then poured into the molds, fully encasing the steel. Workers level the surface and pump concrete into any remaining gaps. Each 24-meter segment requires about 30 hours of work and roughly 3,300 cubic meters of concrete. The concrete is left to cure for several weeks until it reaches its design strength and long-term durability. Once hardened, the formwork is removed, and the 24-meter segment is pushed toward the dry dock. This assembly line process continues until 9 segments are joined into one standard tunnel element, measuring 217 meters long, about 42 meters wide, and roughly 9 meters high. They're huge, aren't they? But do you know how heavy they are? Each element weighs around 73,000 tons. To put that into perspective, it would take roughly 200 modern Boeing aircraft stacked together to match the same weight. The project requires 79 of these ultra-heavy elements, plus 10 special elements. These include an additional technical level for operation and maintenance systems. While the elements are being produced, construction teams simultaneously dredge a trench nearly 18 kilometers long along the Baltic Sea floor. The trench is about 12 meters deep below the natural seabed and roughly 40 to 45 meters wide. This phase is especially challenging because the geology ranges from soft soil to hard limestone. The excavated material is pumped ashore through a pipeline around 2 kilometers long. In total, engineers had to handle nearly 20 million cubic meters of material before the trench was complete. Then comes the most visually striking phase, assembling the tunnel beneath the sea. The key lies in the bulkheads installed at both ends of each element, along with ballast tanks that control buoyancy and sinking. Think of each tunnel section as a concrete submarine. Both ends are sealed with bulkheads to trap air inside, allowing the element to float thanks to buoyancy. At the same time, ballast tanks can be filled with water or emptied, which lets engineers control whether the element floats or sinks whenever needed. Next, once the elements are floating, tugboats pull them out to their installation positions in the Fehmarn Belt. To help move these massive elements out to sea and keep them stable, engineers use immersion pontoons. These are floating structures about 100 meters long and around 45 meters wide. They have a huge lifting capacity of roughly 8,000 tons and are equipped with 66 winches, which allow engineers to adjust the position of each element with millimeter-level precision as it is guided toward the seabed. Once an element reaches its exact location, the ballast tanks are carefully flooded in a controlled way. This increases the weight of the element, causing it to sink slowly and settle precisely into the prepared trench on the seabed. This highly sophisticated sinking process is calculated in advance and carried out using ultra-precise GPS systems and hydraulic sensors. As a result, each element can be positioned with an error of only a few millimeters, ensuring the tunnel remains perfectly aligned and continuous. At this point, you might wonder how engineers make sure the tunnel is truly watertight under the enormous pressure of seawater. You can imagine joining tunnel sections underwater like pressing two sealed boxes tightly together, but instead of using human force, pressure does the job. Each concrete element has very thick C-shaped gaskets at both ends. When two elements are brought close together and aligned precisely, these gaskets already create a mechanical seal, though it is not yet completely watertight. The decisive step works like this. Between the two elements, there is a small chamber sealed off with a temporary steel bulkhead. Engineers pump all the water out of this chamber. Outside, seawater continues to press against the new element, while inside the joint chamber, there is no water pressure. This pressure difference causes the seawater to naturally force the two elements tightly together. Once the joint is completely sealed, the temporary steel bulkhead is removed. An omega gasket is installed from the inside, and reinforced concrete is poured to lock everything in place. The result is a watertight, load-bearing joint designed to last for hundreds of years. The project officially began between 2020 and 2021 on both the Danish and German sides. The seabed trenches have already been completed, and the first concrete elements have been transported out to sea and are ready for installation, with the goal of opening the tunnel in mid-2029. Once finished, it will be the longest combined road and rail immersed tunnel in the world. No immersed tunnel project has ever reached this level of size, weight, and installation precision. The Fehmarn Belt is not just an engineering marvel. It is also a strategic link in Europe's transport network, reshaping connections between Northern and Central Europe for decades to come. If you find this video helpful, don't forget to like and share it so more people can discover it.